is Saxon Math for 6th grade. This is lesson 94, probability. We're doing part B right now. What we learned in our last video is that if we are doing probability of two events that don't really affect each other, we can find the probability of both events happening by multiplying their individual probabilities together. So for example, if we're flipping a coin, the probability of getting heads and then tails would be 1 out of 2 is the probability of getting heads times 1 out of 2, which is the probability of getting tails. Which means that the probability of getting heads and then tails is 1/4. This is called an independent event. It means that these things happen independently of each other. They do not affect each other. There's a different way to do probability if the probabilities will affect each other. These are called dependent probabilities. When you have dependent probabilities, the probabilities are going to affect each other. So for example, whoops, fix my spelling there, sorry about that. Let's say I have a deck of cards. A deck of cards has 52 cards in it. And let's say I have 4 students who want to play a game. My first student comes, here's student 1, and they're going to pick a card. And they're going to hold on to that card and not show me. And then my second student comes and they want to play also, and they're going to hold on to their card. And my third student comes, ignore my really bad drawings. They pick a card, they hold their card too. And then my last student comes because they want to play also, and they hold their card. I have 4 students and each one picked a card. What are the chances? What are the odds? What's the probability that each of these 4 students all selected an ace? For those of you who play cards, there's 4 aces out of all 52 cards. Let's start with the first probability. I want the probability of an ace, and an ace, and an ace, and an ace. Okay, so let's start with the probability that the first kid picked an ace. How many aces were in the deck? Well, there were 4 of them, right? Out of 52 cards. Well, that's easy enough. That's what we've been doing. How many are there that could happen? There are 4 aces. That would be our ace card out of the 52 total. Now I want the probability that this one is an ace and that one is an ace. So we're going to multiply here. And we're going to pretend, just for the sake of argument, that this child actually picked up that ace. He got the ace, and now this kid needs to pick up an ace. How many aces are left? If there were 4 to begin with, and the first kid picked one, there's only 3 aces left. How many total cards are left? There were 52 to begin with. There's only 51 now. Let's move on to our third person. Because I want this to happen, and this to happen, and this to happen, and this to happen. I want an ace, and an ace, and an ace, and an ace. And notice that each one is dependent on the one before it. The probability of this one being an ace changed because we're assuming the first student had an ace also. Let's find the probability that the third student also had an ace. For the record, this is very unlikely. All right. So this student pulled an ace. This student pulled an ace. We're going to see what the probability of this student pulling an ace would be. If there were 4 aces and he picked one, and then there were 3 aces and he picked one, how many aces are left? 2, right? We had 3, he pulled an ace, so there's 2 aces left. There were 51 cards, he pulled that ace out, which means there's only 50 cards left. Now let's look at the probability of our last student picking an ace. Well, there are 2 aces left, and he picked one, so there's only 1 ace left, he would have to pick it. There were 50 cards before, he picked one, so there are 49 cards available now. Notice that each of these probabilities changed because it was dependent on the one before it. That's why these are called dependent probabilities. You solve them the exact same way, multiply together, and then reduce. If you are at all curious what the odds of 4 students all picking aces out of a random deck of cards, if you were to multiply and multiply and then reduce, the answer would be 1 out of 270,725. For the record, those are not very good odds. Whenever you have problems where you have multiple probabilities, and they are for things that are dependent on one another, so each one changes it somehow. Like in this case, we change the deck by taking out a card each time. Multiply the probabilities together, being aware that they're going to be a little different than each other to get your final answer.